It's alternating current. And what is alternating current? It is a current which flows in one direction and then the current reverses its direction. So let us see how this AC current is produced in an AC generator. And to understand this, I welcome you to MT Educare Science Lab. Let us take a look at MT Educare Science Lab, in which we are going to understand the working of AC generator. Understanding AC generator, students, first let us begin with the construction of AC generator. For the construction of AC generator, we'll look at the different parts of a generator. The first part of an AC generator is armature coil. Now what is an armature coil? It consists of a rectangular metal slab on which there is winding of copper. So copper wire is wound on a rectangular metal slab and this is called as armature coil. Looking at the next part. Next, we have two pole pieces of a magnet. So north, that means that side there has to be a south pole. This is a south pole, so that side there has to be a north pole. Or you can also use a horseshoe shaped magnet. So you take a horseshoe magnet and this armature coil is placed between the horseshoe magnet. Looking at the further parts. Here students, we have a slip ring which is an entire ring and the two ends of the armature coil are fitted to the slip rings. After this particular slip ring, the next part is the brushes. So there are two brushes which are connected to the two slip rings. These brushes are generally made from ebonite or carbon. Coming to the last part, and this over here, we have connected it to a galvanometer. Now students, what is a galvanometer? A galvanometer is a device which not only measures the current, but it also shows the direction of current. So you can see the calibration. The needle of the galvanometer is in the center. So when current flows in one particular direction, the needle will move in one direction. And when the current goes in another direction, the needle will move in another direction, thereby showing us the change in the direction of current. So this, students, was the different parts of a generator. So students, let us take a better and a closer look at the AC generator and let us see how it looks from inside. Now you can see from inside, the two ends of the armature coil are connected to the two slip rings. The shorter one connected to the first one and the longer one connected to the second slip ring. So this is how it looks from inside the slip rings. Going further. Now let us understand the working and see how an AC generator actually works. Students, you must have heard about a hydroelectric power station. In hydroelectric power stations, water is made to fall from a certain height and this water contains kinetic energy. With this kinetic energy is used to rotate the blades of a turbine. Now the turbine is connected to that spindle you can see behind. So when the turbine rotates, the spindle also rotates. When the spindle rotates, it will rotate the armature coil. Now let's see what happens when the armature coil rotates. As the armature coil rotates, it cuts the lines of force, magnetic field changes and hence current is induced. So students, this is how the current is induced. So as the armature coil is rotating, it is cutting the lines of force and hence induced current is produced. Now in which direction the induced current is produced can be understood with the help of a rule, and this rule is Fleming's right hand rule. So let us take a look at Fleming's right hand rule. According to Fleming's right hand rule, once again we use three fingers. These three fingers are the thumb. Now if the thumb shows the direction of motion of the conductor, and coming to the second finger is the forefinger, and if the forefinger shows the direction of the magnetic field, then Fleming's right hand rule states that the third finger, and the third finger, that is the central finger or the middle finger will show the direction of induced current. So what is Fleming's left hand rule? If the thumb is showing the motion, the forefinger is showing the direction of magnetic field, then the central or the middle finger will show the direction of induced current. One more understanding from this we get, if the motion is upwards, the current is inwards. It's a very important piece of information. Always when the motion is upwards, the current, induced current, will be inwards. With this understanding, let us go back and understand how current is induced in an AC generator. So students, let us apply this Fleming's right hand rule to the understanding of AC generator. Students, according to Fleming's right hand rule, we know that if the conductor moves upwards, the current will be inwards. Here you can see AB is moving upwards, the current will be inwards. So now the current is flowing from A to B, B to C, C to D, and it is entering from B1. So please make a note of this. The current this time has entered from B1 and it has gone into the galvanometer, and you can see the deflection of the galvanometer going to the right. Now, after completing the first cycle, the current goes into the second cycle, and then the second cycle, the current is entering from B2 and going into the galvanometer. So first cycle, current entered from B1, second cycle, current entered from B2. So that means the current is changing its direction, and that is why this current is called alternating current. In this way, the current keeps on alternating and keeps on changing the direction, which can be seen from the deflection of the galvanometer. This, students, is how AC current is generated. So now, let us connect the AC generator to a bulb and let us see how it works. Now once again you can see the current is flowing from A to B, C to D, and current has entered from B1. So current has entered from B1 and it is going into the bulb. This was the first half cycle of AC generator. In the second cycle, the current has now entered from B2 and it is going into the bulb. So first time current went from B1 and second time the current went from B2. In this way the current is alternating, but it doesn't make any difference to the bulb because the bulb is receiving current either from B1 or from B2. And this is how AC generator is illuminating the bulb.